Space. It's the final frontier. For centuries, humanity has gazed at the stars filled with awe and wonder. We've asked ourselves the biggest questions. Are we alone? Are there other worlds out there like ours? We live in a time of incredible discovery. Telescopes, more powerful than ever before, are revealing the secrets of the cosmos. And what they're finding is astonishing. Planets, it turns out, are not the exception. They are the rule. For a long time, we knew of only the planets in our own solar system. Familiar names like Mars, Jupiter, and Saturn. But now we're discovering thousands of planets orbiting other stars. We call them exoplanets. Our Sun, a star like countless others, has its own family of planets. We've sent probes to some, walked on one, and studied them all with intense curiosity. But what about other stars? Do they have planets too? The answer is a resounding yes. Recent discoveries suggest that planets are more common than stars themselves. For every star you see twinkling in the night sky, there could be multiple planets in orbit around it. These exoplanets are real worlds, each with its own unique story to tell. Some are gas giants larger than Jupiter, while others are rocky, like our own Earth. The sheer variety of exoplanets is staggering. Of all the questions we ask about exoplanets, one stands out above the rest. Is there life out there? Could any of these distant worlds harbor living organisms? While we haven't found definitive proof of alien life yet, the possibilities are tantalizing. Scientists are particularly interested in exoplanets located in the habitable zone. This is the region around a star where temperatures are just right for liquid water to exist on the surface. Water is considered essential for life as we know it. So, finding an exoplanet with liquid water would be a major breakthrough. It would suggest that the ingredients for life are not unique to Earth. The quest for other Earths is more than just a scientific pursuit. So, we've established that exoplanets are out there, scattered across the vast expanse of the Milky Way and beyond. But what exactly are they? How do we define these celestial objects, these distant worlds that we've never actually visited? Defining a planet might seem straightforward. We all know what Earth is, right? A big ball of rock orbiting the sun. But when we venture beyond our solar system, things get a bit more complicated. The universe is a messy place, full of objects that don't fit neatly into our preconceived categories. There are gas giants larger than Jupiter, tiny rocky worlds smaller than Mercury, and everything in between. Some even orbit two stars at once, like something out of Star Wars. To bring some order to this cosmic chaos, astronomers needed a clear definition of what constitutes a planet. Enter the International Astronomical Union, or IAU, the official governing body for all things astronomical. In 2006, the IAU met, and after much debate, agreed upon a formal definition for a planet within our solar system. According to the IAU, a planet must meet three criteria. First, it must orbit the sun. Second, it must be massive enough for its own gravity to pull it into a spherical shape. And finally, it must have cleared its orbital neighborhood of other objects. This last criterion led to the demotion of Pluto from its planetary status. But here's the catch. The IAU's definition only applies to objects within our solar system. When it comes to exoplanets, the rules are a little different. The sheer distance to exoplanets makes it difficult to determine with absolute certainty whether they meet all of the IAU's criteria. So, for now, astronomers use a working definition of an exoplanet that focuses on its mass and its relationship to its host star. An exoplanet is generally considered to be an object that orbits a star and has a mass below the threshold for nuclear fusion. Anything larger than that, and the object would be considered a brown dwarf. As our telescopes become more powerful and our observational techniques improve, we're sure to discover even more exoplanets that challenge our definition of what a planet can be. We may find planets orbiting pulsars, the remnants of exploded stars, or even planets wandering the galaxy without a star at all, rogue worlds adrift in the cosmic void. The study of exoplanets is still in its infancy, but it's already revolutionizing our understanding of the universe and our place within it. So buckle up, space fans, because the journey of exoplanet discovery is just beginning. Imagine trying to spot a firefly next to a blazing spotlight. That's the challenge astronomers face when searching for exoplanets. Stars are massive, luminous objects, while planets are comparatively tiny and faint. Directly observing an exoplanet is like trying to see a dust mote floating in front of a car's headlights from miles away. So how do we find these hidden worlds? Astronomers have developed ingenious indirect methods to detect exoplanets. These methods have revolutionized the field of exoplanet discovery, allowing us to detect thousands of these distant worlds without ever seeing them directly. One of the most successful methods for detecting exoplanets is the transit method. Imagine you're watching a car drive down a long, straight road. As the car passes in front of a distant streetlight, you'll notice a slight dip in the light's brightness. The transit method works in a similar way, but on a cosmic scale. If an exoplanet's orbit is aligned just right from our perspective, it will pass directly between its host star and Earth. During this transit, the planet blocks a tiny fraction of the star's light, causing a small but detectable dip in the star's brightness. By carefully measuring these dips in starlight over time, astronomers can infer the presence of an orbiting planet. Another powerful method for detecting exoplanets is the Doppler spectroscopy method, also known as the radial velocity method. This technique relies on the fact that a star and its planets are engaged in a delicate gravitational dance around their common center of mass. As a planet orbits its star, its gravity tugs on the star, causing the star to wobble slightly. This wobble is too small to be seen directly, but it can be detected by observing the star's light. As the star moves towards us in its wobble, its light waves are compressed, shifting towards the bluer end of the spectrum. As it moves away, its light waves are stretched, shifting towards the redder end of the spectrum. While incredibly powerful, the transit and Doppler methods do have their limitations. Both methods are biased towards detecting larger planets orbiting close to their stars. Small planets like Earth produce much weaker signals, making them harder to detect. Similarly, planets orbiting farther out from their stars take much longer to complete an orbit, requiring years of observations to confirm their presence. However, as our technology improves and we develop new, more sensitive methods, we are beginning to uncover a greater diversity of exoplanets. The search for exoplanets is one of the most exciting and rapidly evolving fields in astronomy. New telescopes, both ground-based and space-based, are constantly coming online, pushing the boundaries of what we can see and discover. The Kepler Space Telescope, launched in 2009, revolutionized the field, discovering thousands of exoplanet candidates using the transit method. Its successor, the Transiting Exoplanet Survey Satellite, or TESS, launched in 2018, is continuing the search, scanning the entire sky for nearby transiting exoplanets. The James Webb Space Telescope, launched in 2021, promises to take exoplanet research to a whole new level. With its unparalleled sensitivity and infrared capabilities, JWST will be able to study the atmospheres of exoplanets in unprecedented detail. The quest to find other worlds is a testament to our enduring fascination with the cosmos. But the story doesn't end with exoplanets orbiting stars. In the vast expanse of space, beyond the familiar orbits of planets around their parent stars, there exists a population of celestial nomads, rogue planets. These intriguing objects, also known as free-floating planets or interstellar planets, drift through the galaxy untethered to any star. Imagine a planet shrouded in perpetual darkness, its surface chilled to frigid temperatures, its skies devoid of the familiar glow of a sun. This is the stark reality of a rogue planet, a world that has broken free from the gravitational embrace of its parent star. The very existence of rogue planets challenges our conventional understanding of planetary systems. These solitary worlds, once thought to be exceedingly rare, are now believed to be surprisingly common. How do planets become rogue planets, cast out from their stellar nurseries to wander the galaxy alone? The answer lies in the complex gravitational interactions that govern the evolution of planetary systems. During the chaotic early stages of a planetary system's formation, young planets can be ejected from their orbits due to close encounters with other planets or with nearby stars. These gravitational slingshots can propel planets to incredible speeds, casting them out into interstellar space. Once ejected, a rogue planet is no longer bound to its parent star, destined to wander the galaxy alone. Shrouded in darkness and perpetually cold, rogue planets are a far cry from the planets we're used to imagining. Without a star to provide light and heat, rogue planets are likely to be incredibly frigid places, their surfaces locked in a perpetual deep freeze. But while their surfaces may be inhospitable, some scientists believe that rogue planets could still harbor internal oceans of liquid water. This internal heat, combined with the potential for hydrothermal vents, could provide the necessary conditions for life to exist. Rogue planets are thought to come in a variety of sizes and compositions, ranging from small, rocky worlds like Earth to massive gas giants larger than Jupiter. Studying rogue planets can provide valuable insights into the diversity of planetary systems and the processes that govern their formation and evolution. Finding rogue planets, these dark, solitary worlds adrift in interstellar space, is no easy feat. They emit no light of their own, and their vast distances from Earth make them incredibly faint and difficult to detect directly. However, astronomers have developed ingenious techniques to uncover these hidden worlds, relying on the subtle effects they have on light passing by them or on the movements of nearby stars. One such technique is gravitational microlensing. Gravitational microlensing exploits the fact that massive objects like planets can bend and magnify light from more distant stars as they pass in front of them. When a rogue planet passes in front of a background star, it acts like a lens, causing the star's light to brighten temporarily. This brightening, while subtle, can be detected by telescopes, revealing the presence of the unseen planet. Another method for detecting rogue planets is through direct imaging. While challenging, this technique is becoming increasingly feasible with the advent of more powerful telescopes and advanced imaging technologies. By blocking out the light from a star, astronomers can sometimes directly image faint objects orbiting nearby, including rogue planets that have been ejected from their systems. The study of rogue planets is still in its infancy, but it has already revolutionized our understanding of planetary systems and the potential for life beyond Earth. These cosmic wanderers, once thought to be mere oddities, are now recognized as a significant population of objects in the galaxy, perhaps even outnumbering stars. Their existence challenges our assumptions about the conditions required for planet formation and habitability. Could life, we wonder, arise on a world bathed in perpetual darkness, sustained by internal heat and the chemical energy of hydrothermal vents? The possibility, while remote, is tantalizing. Rogue planets also offer a unique opportunity to study the evolution of planets in isolation, free from the influence of a star. By analyzing their atmospheres and compositions, we can gain insights into the processes that shape planets over billions of years. The discovery of rogue planets has expanded our view of the universe, revealing a cosmic landscape more diverse and wondrous than we ever imagined. As we continue to explore, we can only marvel at the endless possibilities that await us in the vast expanse of space. Imagine yourself as a detective, but instead of a dimly lit alleyway, your crime scene is the vast, star-studded expanse of the Milky Way galaxy. Your mission? To track down elusive rogue planets, worlds that roam the galaxy without a star to call their own. These cosmic wanderers are incredibly difficult to find. They emit no light of their own, making them practically invisible against the backdrop of billions of stars. It's like trying to spot a speck of dust in a hurricane. But don't worry, our cosmic detectives have a few tricks up their sleeves. Over the years, astronomers have developed ingenious methods to detect these elusive worlds, using the very fabric of space-time to their advantage. They've become experts at reading the subtle clues that rogue planets leave behind, like cosmic breadcrumbs, leading us to their hidden locations. These methods, though indirect, have already revealed a surprising number of rogue planets, suggesting that they might be more common than we ever imagined. And as our technology advances, we're getting better and better at spotting these galactic nomads, slowly lifting the veil on a population of planets that were once shrouded in mystery. One of the most successful techniques for finding rogue planets is called gravitational microlensing. It's a bit like playing cosmic billiards, but instead of using a cue stick, we rely on the immense gravity of massive objects. Here's how it works. Imagine a distant star far beyond our solar system. As a rogue planet passes in front of that star, its gravity acts like a magnifying glass, bending and amplifying the star's light as it travels towards Earth. From our perspective, we see the star temporarily brighten as the rogue planet passes by like a cosmic blink. The duration and intensity of this brightening effect tell us a lot about the rogue planet itself, including its mass and distance from Earth. Microlensing events are rare and fleeting, lasting only a few days or weeks. But by continuously monitoring millions of stars, astronomers have been able to detect a surprising number of rogue planets using this method, proving that these wandering worlds are not as uncommon as we once thought. While microlensing relies on chance alignments and the bending of light, another method allows us to directly image these elusive worlds. It's called, appropriately enough, direct imaging, and it's a testament to the incredible advancements in telescope technology. Direct imaging is like trying to spot a firefly next to a spotlight. The challenge lies in blocking out the overwhelming glare of the host star, which can be billions of times brighter than the faint glow of a rogue planet. To achieve this, astronomers use specialized instruments called coronagraphs, which are essentially high-tech masks placed within telescopes. These coronagraphs block out the starlight, much like how you might use your hand to shield your eyes from the sun, allowing the faint light of nearby objects, such as rogue planets, to be detected. Direct imaging is most effective at finding young, massive rogue planets, as these objects still retain some of the heat from their formation, emitting a faint infrared glow that telescopes can detect. While this method is still in its early stages, it holds immense potential for uncovering a treasure trove of rogue planets in the years to come. In 2020, astronomers made an exciting discovery using the microlensing technique. They found a rogue planet so small that it was unlike anything they had ever seen before. This tiny world, named Ogle 2016, BLG 1928, is estimated to be less massive than Earth, possibly even smaller than Mars. This discovery sent ripples of excitement through the astronomical community. Until that point, most rogue planets we had detected were gas giants, several times larger than Jupiter. Finding such a small rogue planet suggested that these Earth-sized wanderers might be incredibly common in the Milky Way. Ogle 2016, BLG 1928, is a true enigma, a world adrift in the vast emptiness of space. We know very little about it, other than its approximate mass and the fact that it's not bound to any star. But its discovery has opened up a new chapter in the study of rogue planets, hinting at a population of small, rocky worlds that could be more numerous than stars themselves, each with its own unique story to tell. The study of rogue planets is a field on the cusp of revolution. With the launch of powerful new telescopes like the James Webb Space Telescope and the development of even more advanced detection methods, we're entering a golden age of rogue planet discovery. These technological advancements will allow us to study rogue planets in unprecedented detail. We'll be able to analyze their atmospheres, if they have any, searching for clues about their composition and origins. We might even be able to detect the faint glow of internal heat, hinting at the possibility of hidden oceans beneath their frigid surfaces. The future of rogue planet hunting is bright, filled with the promise of groundbreaking discoveries that will challenge our understanding of planetary systems and the vast cosmic tapestry. Who knows what other secrets these wandering worlds hold? Perhaps they harbor the building blocks of life, or maybe they hold clues to the very formation of the universe itself. Only time and continued exploration will tell. From the swirling clouds of gas and dust, planets emerge, orbiting their parent stars in a delicate gravitational ballet. We've journeyed far in our understanding of these celestial objects, venturing beyond the familiar faces of our own solar system to explore the incredible diversity of exoplanets scattered across the cosmos. We've delved into the intricate methods astronomers use to detect these distant worlds, from the telltale dips in starlight caused by transiting planets to the subtle wobbles of stars betrayed by the gravitational pull of unseen companions. We've marveled at the sheer variety of exoplanetary systems, from gas giants larger than Jupiter to rocky worlds that might harbor liquid water and perhaps even life itself. And we've peered into the shadowy realm of rogue planets, those cosmic wanderers adrift in the interstellar void, unbound by the gravity of any star. We've explored their mysterious origins, pondered their potential for harboring life in the absence of sunlight, and recognized their significance in shaping our understanding of planetary formation and the vast cosmic web that connects us all. The quest to understand our place in the universe is an ongoing journey, a never-ending exploration driven by our insatiable curiosity and our desire to unravel the mysteries of the cosmos. With each new discovery, with each tantalizing clue, we inch closer to answering the fundamental questions that have captivated humanity for millennia. Are we alone? What other secrets lie hidden among the stars? The universe is vast, filled with wonders beyond our wildest imaginations. And as we continue to explore, we can only marvel at its beauty, its complexity, and the infinite possibilities that await us among the stars. If you've enjoyed this cosmic adventure, don't forget to like this video and subscribe to our channel for more explorations of the universe and its many wonders. Until next time, keep looking up and never stop questioning the cosmos.